So in the time value of money chapter, here we focus on the present value of an annuity. So normally we should understand what is an annuity. These are equal stream of cash flows. It can be cash inflow or it can be cash outflow, but the only one feature that has to justify that cash flows are equal in magnitude. There are ample examples for this, like if I want to just know how much I can borrow to buy a car. When I buy a car, I have to pay EMI, right? So I have to see my capacity of paying EMI. Suppose my capacity is 20,000 per month, right? Then this 20,000 is EMI means equated my monthly installment. I have to pay 20,000 for a certain period of time for every month. So as these 20,000 are equal in all the months, so we call it annuity. The figures are equal. How much can you withdraw periodically on a lump sum deposit today? Suppose you retire from job and you have 20 lakhs, you are depositing this 20 lakhs and you plan to draw these 20 lakhs in small equal amounts for next 15 years. So these equal amounts are actually annuities. Suppose you are planning to you are planning to see that how much time it will take to repay your loan. You are preparing a loan amortization schedule. Now loan amortization means your repayment of loan, and if the repayment happens by paying an equal amount, then these equal amounts are called annuities. So essentially an annuity means an equal stream of cash flow. It can be cash inflow, it can be cash outflow. How do you solve it? Let us see. Now this is my formula of calculating future present value of an annuity. PVA stands for present value of an annuity. Now the first term here is A, that is my annuity, and the timeline looks like this. So this is my timeline. This is today. Suppose this is year 1, 2, 3 and 4. So let me write first. This is year 0, that is I am standing today. Year 1, year 2, year 3 and year 3 and year 4, right? Now I'm actually having some cash flow at certain points. Suppose at the end of year 1, at the end of year 2, at the end of year 3, at the end of year 4. What I want to calculate is what is the present value of all these future cash flows, right? What is the present value of these cash flows that are occurring in future? It can be cash inflow, it can be cash outflow. So I just want to calculate the value here, that means value today. So we call it present value, right? And as this present value are for equal stream of cash flow that are going to occur in future, so we call it a problem of present value. We call it a problem of present value of an annuity. So this is a present value, not a F, but this is PVA, right? So this is how we actually basically deal the present value of an annuity problem. We'll see a small sum and we'll check how this present value of an annuity problem works. Okay, so suppose you expect to receive 1,000 rupees annually for 3 years, each receipt occurring at the end of the year, right? That is, it is a case of ordinary annuity. When cash flow occurs at the beginning of the year, we call it annuity due. When it occurs at the end of the year, we call it ordinary annuity. What is the present value of this stream of cash flow if the discounting rate is 10%? It is a discounting rate because not a compounding. Compounding is to calculate the value in future. Discounting is I have a value in future, I want to calculate the value today. So it's a 3-year problem, right? So my tenure n is 3, and what I am getting here is I'm getting 1,000 at the end of year 1, same 1,000 at the end of year 2, 1,000 at the end of year 3. As all these are 1,000, so we call it an annuity. Now this 1,000 rupees, I can solve it in 3 ways. First, I can individually convert this 1,000 rupee into present value. How do I do that? See, 1,000 rupees, my discounting rate is 10%, right? Discounting rate is 10%. So what I can do, I can take this 1,000 rupees divided by 1 plus 0.10. This is 1 plus 0.10. It is a little bit out of screen. 1 plus 0.10 to the power 1. So I get the value here, right? This is the value. This is the value. 1 plus 0.10 to the power 1. I'm discounting for 1 year. Next one, this one I'm discounting for 2 years, I get the value here, and the third one I'm discounting for 3 years, I get this value. Once I add these three values, I get the answer 2486.85. that is 2487 approximately. So this is how I solve when I don't use a present value of an annuity formula. But as these are annuity, ideally it's not a smart way of solving it. As it's an annuity, so we have to solve it using the annuity or present value table. Let us see how it works in that way. So this is my present value table. This is my present value formula, right? Now in this formula, this my cash flows are 1000. My cash flows are 1000. My annuities is 1000. Discounting rate is 10% and 10 year is 3 year. So 1000, I replace 1000. 1 plus r is 10%, 0.10 to the power n is 3, right? Minus 1 divided by, my formula is this, r into 1 plus r to the power n. So 0.10 into 1 plus 0.10 to the power 3. Once I solve this particular part, then I get the answer of 2.487, right? Once I multiply this with 1000, I get an answer of 2487. You can see that instead of individually calculating the numbers or into present value, I can take this formula, right, and I can solve it easily. Even I have an easier way to solve it, and that is by using a table, right? I can see the table. Now this is my formula, what I use here. Now I can replace this formula with this particular table. What this table actually will give you, the result of this particular calculation of this part. What you calculate in this, within this particular formula, within the parentheses, that will be given in the table. So PVA will become A, annuity, into PVIFA, stands for present value of interest factor of an annuity. So we will refer to this table when it is an annuity. It's a present value table plus present value annuity table. So these two things we have to keep in mind. Now this R stands for here 10% and n is 3 years. So I have to look for a value in the PVIFA table for r equal to 10%, n equal to 3 years. Let me check PVIFA table. When I go to PVIFA table, let me check once. My PVIFA table, r equal to 10% and 3 years. So this is my value, if you can see here. So let me first clean this. This is my value, 3 years and 10%. So this is my value, 2.487, right? So once I just replace this value here, right, then I get the answer. So 1000 is my annuity into PVIFA. I get the table value 2.487. So it replaces my calculation. I just multiply this, I get the answer, right? Now we can solve a little bit of generic problems using this also. So first problem is to understand whether it's a present value problem or future value problem. So you have to draw a timeline and understand that. In the next small video, we'll do this. We'll solve these problems.